Okay, so 5 to the 1 minus 3x is 1 over 25. Then if you think about it, can 25 is a power of 5, right? So this is the same as saying 5 to the 1 minus 3x is 1 over 5 squared. This is going to say that 5 to the 1 minus 3x is equal to 5 to the minus 2. Now the bases are the same, so the exponents must be equal. 1 minus 3x equals minus 2, and now you can solve for x. So minus 3x equals, oh, isn't that cute? Minus 3, x equals 1. Only in an algebra book. Never in real life. The answer is 1. Now, this is one of those problems where I look at it is that the smaller number is 4. 4 can't be written as a base of 32. 32 can't be written as a base of 4. And given the way this thing is written, as we get into 5.5, I believe is where it is, this can be an butt ugly problem if you try to use a 5.5 method on it. You can still get the answer, but it's really bad. But I also noticed that if I go down to powers of 2, that 4 and 32 are both powers of 2. So they both can be written to a base of 2. So technically speaking, when I write this, 4 is 2 squared, that's your base, to the x plus 5 is 2 to the 5th to the x. Or you could say 2 to the 5x. Now why I did this was this. This is still the same equation. 4 is 2 squared. I put it in parentheses because that was my base. 32 is 2 to the 5th. I put it in parentheses because that was my base. You're going to say, well, why in the world would you do that? Because now we're going to be using the properties of exponents to multiply the exponents. So this becomes 2 to the 2 times x plus 5 equals 2 to the 5x. Now, by the way, you don't have to write every step that I write. I put in probably twice as many steps as you might put in at times. And why? Because if I leave something out, suddenly you will want to know where it came from. So that way, if I put it all in, you might say, oh, gee, why did she do that? Well, I can guarantee you there's somebody that's going to be sit there and say, duh, where did that come from? So that kind of gets everybody covered. So now we follow through. The bases are the same, so the exponents are equal. So this says 2 times x plus 5 equals 5x. And now you've got a simple linear equation. 2x plus 10 equals 5x. Subtract 2x, 10 equals 3x. Divide by 3. X equals 10 divided by 3. That's more like it. It's not an ugly fraction, but it is a fraction. I mean, I hate to solve a problem. You spend so much time solving a problem and the answer is 1. It's like, I did all of that work and for a measly 1 is an answer. Now here we're going to be playing with properties of exponents because the only thing that what I need to have happen is this. I need to have a base to an exponent equaling the same base to an exponent. I can't have divisions and multiplications. I need one thing to an exponent equaling one thing to an exponent. That means I have to use the properties of exponents because bases are the same to bring these together. So e to the x times e to the x minus 6 is if the bases are the same. In this case, you're going to add the exponents. On the other side, you've got a division where the bases are the same. Properties of exponents say you subtract the exponents. So now I have what I'm looking for. I've got e to the something equaling e to the something, so the two somethings must be equal, right? So x plus x minus 6 has to be equal to 3 minus x. 2x minus 6 is equal to 3 minus x. Add x to both sides. 3x minus 6 equals 3. Oh, isn't this cute? Book problem. Add 6 to both sides. 3x is equal to 9. Divide by 3, x is 3. I like it when it works out nice. At least it's not a 1.